this video I'm going to start chapter 11, which is all to do with speed, distance and time. So as usual, the first kind of section is just a recap on what you should know already and you've covered before last year. So our equation for speed is speed equals distance over time. And one thing that's really important is that you're aware of the units for speed. So there's two different units for speed, or well, there's more than two, but there's two that you'll see. And one of them is if the distance is given in meters and the time is given in seconds. Speed then is measured in meters per second. Meters per second can be written like this, or it can be written like this. Two ways to write the same thing. So let's say something has a speed of 10 meters per second. What does that mean? It means that it travels 10 meters every second. So without even needing to rearrange this equation, if I asked you, well, how far would it travel in 5 seconds? Well, if it travels 10 meters every second, in 5 seconds it would be 10 meters per second by 5. It would travel 50 meters. Now what we've done there is we've actually rearranged the equation without actually thinking about it, just by looking at the units. Distance is the speed times time. 10 meters per second for 5 seconds is 50 meters. Now notice as well how I got my unit for distance as meters, because this is in meters per second. The other unit that you'll often see speed given in is kilometers per hour, and that's when the distance is given in kilometers and the time is given in hours. So it can be written like this, kilometers per hour, or it can be written like this, and both of these are the same thing. So this is our equation for speed. Now sometimes what they'll do in a question is they'll give you different stages. So they might say a car travelled at 10 meters per second for 5 seconds, and then it slowed down and travelled at 5 meters per second for 3 seconds. So stage 1 and stage 2. Now when that happens, sometimes they'll ask you to find the average speed. And if they ask you to find the average speed equals total distance over total time. So what you need to do is you need to get the total distance travelled, the total time, and then divide the total distance by the total time. Do not get the average of the two speeds, because that will give you the wrong answer, and I'll talk about that in another video maybe. One of the trickier questions that they might ask you to do is they might ask you to convert units. So they might say to you, well, what is 600 meters per second in kilometers per hour? Or they might ask you to do backwards. Now here's how I solve this. I write this as a fraction. That would be 600 meters in 1 second. And if I want to change that to kilometers per hour, I want to write the top line in kilometers and the bottom line in hours. So 600 meters to kilometers, well, there's 1000 meters in a kilometer. So if I wanted to figure out what 600 meters is in kilometers, it would be 0.6 kilometers. I divide by 1000. Now, seconds to hours. Well, in 1 hour, there is 3600 seconds, which is 60 minutes by 60 seconds. So if I want to get seconds in hours, I need to divide by 3600. So it's 1 divided by 3600 of an hour. Now I type that into my calculator and it will give me an answer of 2880 kilometers per hour. But I find it easier if you write it like this. Convert the meters to kilometers, the seconds to hours, and then just divide. So I'll do one more example of them going from kilometers per hour to meters per second. So let's say we have 63 kilometers per hour, and you're asked to write that in meters per second. Well, that's 63 kilometers over 1 hour, which would be 63,000 meters, because there's 1000 meters in 1 kilometer, over 3600 seconds. Now you have it in meters per second. You just have to divide 63,000 by 3600, and that gives you 17.5 meters per second. So it takes a bit of practice with them, but it's really easy once you get that kind of strategy right. The next thing you might be asked with distance and speed and time is looking at distance time graphs. And again, you've covered these before, so I'm just going to do a quick recap. Distance in meters, let's say, time in seconds. So what a distance time graph does is it tells you the distance from a specific point at a certain time. So somebody might start at point X. Now point X, if you're at point X on time 0, your distance from it is 0 meters. So you're standing on point X. Now if you start to walk away from X over time, 5 seconds later, you might be 5 meters from X. So this tells us that a forward sloping line going upwards means you're moving away from the object. Now if we look at this, we could say, well, what if I wanted to find the slope of this line? And the slope of the line is rise over run. Well, what's the rise in this case? It's 5 meters. And what's the run? 5 seconds. And what you'll notice is you're actually dividing distance by time. So the slope equation is the same as distance divided by time. The slope equation is the same as the speed equation. So this will actually give you the speed. So that's a really, really important fact to know. The slope of a distance time graph, and it has to be a distance time graph because we'll do other graphs as well, so make sure you remember it only works for distance time. The slope of a distance time graph is equal to the speed. So now without even calculating the speed of this next object, let's say I had another object whose graph looked like this. Is that object moving faster or slower? Well, it has a higher slope or a steeper slope, which means the slope is bigger, so that means it has a greater speed. Likewise, another object whose distance time graph looks like this, a shallower slope, so it has a lower speed. What if we had an object that slope looked like this? What can we say about its speed? Well, because the slope is changing, that means the speed is changing, and that's really, really important. So, is the speed getting bigger or is it getting smaller? Well, when you look at it, at the start we have a really shallow slope. If I wanted to find the slope at this point, it'd be really, really shallow. And as we move along, as time continues, that slope starts to get steeper and steeper. So we're going from a shallow slope to a steep slope, which means that it's speeding up, or in other words, it's accelerating. So we can tell this just by looking at the shape of the graph. One more, what if I had a slope that looked like this? Now this time we're going from a really, really steep slope to a shallower slope. So in this case, the slope is changing, which means the speed is changing, but this object isn't accelerating, this object is decelerating. Last thing very quickly, and it's something that you've covered before, so you're probably fine with it, but that means that the object is moving forward at a constant speed. If you have a flat line on a distance time graph, well, time is continuing on, time doesn't stop, but the distance isn't changing. This object or person is still 5 meters from the original position. So a flat line means that the object is stationary. And finally, a line going backwards means that the object is returning to X. And with the line going backwards again, you could have a line which has a changing slope. So it could be just like before, where the slope is starting shallow and then getting steeper. So that just tells us that the speed is changing. So that's a quick recap on everything you need to know. You need to know about distance time graphs, and what the slopes mean, the fact that the slope of a distance time graph gives us the speed. That's just a slope of a distance time graph. Sorry, it's really messy when I'm writing on this. Slope of a distance time graph gives us the speed. A flat line is stationary. You need to know how to convert between meters per second and kilometers per hour, and you need to know the average speed equals total distance divided by total time.